Hello everyone, this is part 6 video on past year NEET questions from the chapter laws of motion. Now those who are looking at this video, right, can also take a look at the previous 5 parts so that you'll have continuity of questions. We'll start with a question that has come in the year 1990. This is a question based on the rocket propulsion. A 600 kg rocket is set for a vertical firing, means we want to fire this rocket vertically up. If the exhaust speed is 1000 meter per second, the mass of the ejected gas per second to supply the thrust that is needed to overcome the weight of the rocket. So before we go into the details of this question, right, let us try and understand a bit about how the rocket propulsion mechanism will actually work. I'm sure a lot of us would have seen, if not in reality, at least on TV, the launching of a rocket from the launch pad. So what is the observation that we are seeing? There is a huge amount of this exhaust gas that is coming downwards, isn't it? The exhaust gas is coming downward, and we see that as a result the rocket is moving up. This is the general observation that we have. Now if you look at now what is actually happening in terms of the rocket propulsion through the physics perspective or mechanics perspective. So let us say, for example, we have a rocket. Okay. So what is this rocket doing? There is a fuel that is getting burnt, and that exhaust gas is pushed or ejected back. So initially, when the rocket is sitting on the launch pad, right, what is the initial momentum? We are looking at the very initial stage. Like when we're sitting on the launch pad, what is the initial momentum? It is 0. Now as this exhaust gas is pushed back, see what is happening. Let's say it is coming backwards with that speed. What is the speed here? In this case, exhaust speed is what? 1000 meter per second. Generally we'll represent this by the symbol U. If say in a time t some m dash, why I am not using m is because in equations about the rocket, right, generally m is used to represent the mass of the rocket. Okay, so in a time t, m dash mass of the gas is ejected. Now initially, what is the velocity of this gas? 0, but as it is pushed backwards, it is getting a velocity u, right? So the mass m dash is getting a change of momentum. From 0 it is getting a momentum of what? M dash into u. Time taken for this is what? T. So if you look at what is the rate of change of momentum, change in momentum by the time taken. So here this is basically the thrust, or we'll say the force acting on the gas that is pushed back, isn't it? It's nothing but what? The rate of change of momentum of this gas. Now as per the Newton's third law, right, the gas that is ejected back or down will in return apply a thrust on the rocket that will be upwards. So this is what we call as the thrust of the rocket, or thrust acting on the rocket. So there will be a thrust that will be acting on the rocket because of the gas that is ejected back or downwards. So if you look at m dash by t means what? The mass of the gas that is ejected divided by the time. This is what we call as the rate of the ejection of gas. At what rate the gas is being ejected downwards, into, we'll multiply this with the speed, m dash by t into u. That is going to give us what? This will be giving us what is the thrust acting on the rocket, and the thrust is what is going to push the rocket up. Okay, so this is the basic working of the rocket. And for the rocket to get lifted up, right, what must happen? You know, on the rocket already there will be weight acting. The weight of the rocket is what? Mg, right? So if the upward thrust is more than mg, means the rocket will get lifted. So if the thrust is more than mg, means what? The rocket will experience a net acceleration. So that will be given by what? The upward thrust minus mg is equal to what? Ma. This is how we look at the net acceleration of the rocket. So we'll come to this particular problem here. So what is it? So we have a rocket which is having a 600 kg mass. So here, the mass of the rocket is what? M is equal to what? 600 kg. The exhaust speed, that is generally will represent by the symbol U. Exhaust speed is what? 1000 meter per second. So we are looking for the mass of the gas that is ejected per second to supply the thrust needed to overcome the weight of the rocket. So here we are looking for the situation where the thrust rate is just able to overcome the weight of the rocket. So here weight of the rocket means what? What is the weight of the rocket? Weight of the rocket is equal to what? It's nothing but 600 kg. So we'll consider G as say 10 meter per second square. So weight means what? M into G, right? So it will be what? 600 into 10, that is what? 6000 newtons. That is the weight of the rocket. The thrust, upward thrust, is coming because of the downward ejection of the exhaust gas. Now here, if M is the mass of the rocket, what we need to understand is the exhaust gas is coming from nowhere but within the rocket, right? Because where is the fuel stored initially? Inside the rocket. So the fuel is burnt and that is being ejected backwards, which means as the rocket is propelling in the forward direction or upward, the mass of the rocket keeps changing. It in fact decreases. It will be what? Decreasing. So look at this. dm by dt represents what? The rate at which the mass of the rocket is changing. Minus dm by dt means, because we should understand that dm by dt will be negative. Minus dm by dt will be what? The rate at which the mass of the rocket is decreasing. When we put minus means this indicates what? The rate of decrease. And this minus dm by dt, the rate at which the mass of the rocket is decreasing, right? That is the rate at which the exhaust gas is being ejected down, because whatever the loss of mass for the rocket, right, that is what is coming out as the gas, which means what? Minus dm by dt, it represents what? It represents the rate at which the gas is ejected from the rocket. It represents what? The rate at which the gas is ejected from the rocket. Okay. So here the upward thrust formula. What is the upward thrust? Upward thrust is what? The rate at which the gas is ejected, in this case minus dm by dt, this is what we are trying to find, into U, right? The exhaust speed, which is what? 1000 meter per second. Now we are looking at a condition where the upward thrust is able to exactly balance the weight of the rocket, which means what? Minus dm by dt. In this problem we have spent some time to understand the background of it, but otherwise generally this is a straightforward formula based kind of question. Okay, so minus dm by dt into 1000 meter per second is equal to what? Weight of the rocket is 6000, so 1000 once 1006. So minus dm by dt, unit will be what? SI unit, 6. What is it? Kg per second. So that is the rate at which the gas will be ejected from the rocket. What is the answer for this? It is option C. Now we'll have 3-4 more problems based on the rocket propulsion. We have spent some time to get the basics so that in the next couple of problems, right, we will be able to replicate these things. Let us look at another question. This is also based on the rocket propulsion. This has come in the year 1994. In a rocket, fuel burns at the rate of 1 kg per second. What is the rate at which the fuel is burning? 1 kg per second. This fuel is ejected from the rocket with a velocity of 60 km per second. See, you have to be careful about the units. Why? Because when we say 60 km, so this is the fuel is ejected from the rocket with a velocity, means this is our U. U is what? 60 km per second, means we should convert this into SI unit. What is it? It will be 60,000 meter per second. In the rocket, fuel burns at the rate of 1 kg per second, means what? This is our minus dm by dt. So where m is what? Mass of the rocket. So minus dm by dt means what? This is the rate at which the mass of the rocket is decreasing, and that is also what? The rate at which the fuel is burning. So this is what? 1 kg per second. This is already in the SI system of unit. So in this particular case, they are asking the force exerted on the rocket. So look at it, it's a straight formula question. So what is that thrust? What will be the thrust acting on the rocket? It is what? Minus dm by dt, the rate at which the fuel is burnt or the gas is ejected, into the exhaust speed, isn't it? So what is it? This is 60,000 meter per second into 1 kg per second. What is it? 60,000 newtons. So what is the correct answer for this? It is option. So maybe the diagram, we can just look at it. This is the diagram, we can look at it. So what is happening? The exhaust gas is coming back. As a result of the exhaust gas being ejected down, right, there will be a thrust, upward thrust acting on the rocket. So what is the formula for the upward thrust? The rate at which the exhaust gas is ejected into the exhaust speed. That's it. So what is the answer? It is option B, 60,000. See, on rocket propulsion, if we understand the basic formula and how they are coming, right, if you look at past year questions, most of the questions are straight formula based. Next we have another question. This has come in the year 1998. A 5,000 kg rocket is set for the vertical firing. Exhaust speed is, so this is what mass of the rocket, this is what U, exhaust speed. To give an initial upward acceleration of 20 meter per second square, means here we are looking for an acceleration for the rocket. The amount of the gas that should be ejected per second to supply the needed thrust is, means look at this, what is happening here. The ejected gas is coming down. The rate at which the gas is ejected is what? Minus dm by dt. Okay. The upward thrust will be equal to what? Here, what is that upward thrust? Upward thrust is equal to what? Minus dm by dt into u. Here also they are asking us to find what is this minus dm by dt value. They are asking us what? The amount of the gas ejected per second to supply the needed thrust. Here, what is the thrust that they are looking for? They are looking for a thrust so that the rocket will net have an acceleration upwards. How much it is? 20 meter per second square. Now look at the force balance. Already on the rocket there will be weight acting downwards, right? So the upward thrust minus downward there is a weight, which should be equal to what? Mass of the rocket into acceleration. Correct. Now from here, upward thrust that is required is equal to what? The minus mg will come to the right side. It will become what? Plus mg. So we'll have what? Mg plus ma, which is m into g plus a, means m is 5,000 into g plus a, means what? G is 10, a is 20, so it will be what? 30. Everything is in the SI system, which means what is it? This is 1,50,000 in terms of Newton. This is the upward thrust. But what is the upward thrust value? Minus dm by dt. We have seen this relation in the previous questions also. Minus dm by dt into u, right? This is what? 1,50,000 newtons. What is u given here? 800, right? U is given as what? 800. Means now it's just a simplification only. We got the answer. So what is the minus dm by dt is what we are trying to find here, right? We are trying to find what is the minus dm by dt value. That is the rate at which the gas is ejected. So what is it going to be? Minus dm by dt is what? 1,50,000 by u. The u will go to the right side into the denominator. So look at this. We are in the final step. The minus dm by dt, we will hold it onto the left side only. Minus dm by dt is equal to what? 1,50,000 divided by u is what? 800. Everything is in the SI system. So this value is going to come in which unit? Kg per second it is going to come. So hundreds will cancel. So what is it? 15,000 by 8. What is 15,000 by 8? It will be 187.5. What is 15,000 by 8? It will be what? 187.5. So 187.5 kg per second, right? That is what is the rate at which the gas is ejected, or the amount of the gas that is ejected per second in order to give the rocket required upward thrust. So what is the correct answer for this? It is option B. Next we have a question that has come in the year 1992. This is a basic question on the application of the idea of friction. Consider a car which is moving along a straight horizontal road with a speed of 72 km per hour. If you want to convert this into meter per second, means what we have to do? 72 into 5 by 18. That is like what? 18 ones, 18 fours. What is it? 20 meter per second. If the coefficient of friction between the tires and the road is 0.5, means what? So we have the road and there are these tires. This is a car. Okay. The shortest distance in which the car can be stopped is, means once we apply the brakes, the wheels will stop rotating. Then the wheels will be essentially sliding. So there will be a frictional force that will be acting in the opposite direction. There will be a frictional force that will be acting in the opposite direction, which means what? Here the frictional force will try to stop the car once we apply the brake. The question is, they're asking in how much shortest distance the car will basically stop. See, for this, right, if you look at the car, there is a weight of the car acting downwards, and there will be the normal reaction. Particularly there is no motion, right? Means what? Normal reaction is equal to weight of the car. Frictional force is what? Mu into the normal reaction, which is what? Mu into mg. So the acceleration coming because of friction, of course the acceleration will be opposite to the direction of motion. Acceleration coming from the friction is what? Mu mg by m, because force divided by mass, right, which is what? Mu into g. Mu is how much? 0.5. G is what? 10. So 0.5 into 10 means what? This is 5 meter per second square. We should keep one thing in mind, that this acceleration is in opposite direction to the initial velocity. So before we applied the brakes, right, what is the initial velocity? They have given it as 72 km per hour, but we'll take the SI unit, right? 20 meter per second. So initial velocity is what? 20 meter per second. Acceleration is opposite direction, like the way we do in the straight line motion, right? Since the acceleration is in opposite direction, what do we take it as? We will take it as negative. We have to follow the sign convention, right? So look at it. It is like motion in a horizontal straight line, right? So what do we have? Initial velocity u is equal to what? Plus 20. Acceleration we will take it as minus 5. Understand why we are taking minus 5? Because it is in opposite direction, right? We need to find the displacement till it comes to rest. Stopping means what? The final velocity will be 0. What is the formula? S is equal to what? V square minus u square by 2a, right? Which is v square is anyway 0 minus u square 20 square divided by 2 times of a. Minus minus is cancelled. 20 square means what? 400. Denominator is what? 2 5s are 10. How much it is? 40 meters. So what is the answer for this? 40 meters. So here we are just getting that acceleration that is generated by the frictional force, and then using that kinematics equation, stopping distance formula. Next we have an interesting question. This has come in the year 1991. Of late, right, we have not seen questions of this model. A heavy uniform chain. Uniform chain means what? If you take the chain to be like a one-dimensional object, right? For these kind of objects, we can define something called as linear mass density. Linear mass density means what? If you take some length, we look at what is the mass divided by the length of that particular element. That will be what? Constant. That is what we call as the uniform chain. Okay, so we have a horizontal heavy uniform chain which is lying on the horizontal tabletop. Okay, so maybe we can just represent it like this. So we have a horizontal table, the heavy chain is lying on top of the table. If the coefficient of friction between the chain and the table surface is 0.25, then the maximum fraction of the length of that particular chain that can hang over one of the edge of the table means what? You have the chain like this, means okay, this is the table. They are looking at a condition where what is the maximum fraction of the length of the chain that can hang when the coefficient of friction between the table surface and the chain is what? 0.25. So here what we will start with is, see, what do you mean by this condition of maximum fraction of the chain that is hanging? Whatever the because here if you consider capital M as the mass of the chain, total mass, okay, and capital L is the length. If x is the fraction that is hanging, x is the fraction, means the mass of this particular part, right? If x is the fraction, means mass of this particular part will be what? It will be x into capital M, because if the total mass is m, x is the fraction of the chain that is hanging, the mass of that portion will be what? X into m. The mass of the portion that is on top of the table is what? It will be, remaining fraction will be what? 1 minus x, right? The mass of this will be 1 minus x into m. So the weight of this hanging part will be what? Mass of the hanging part into g. This will try to actually pull the chain down. So the chain on top of the table will have a tendency to move towards the right side. What is the opposing force for that friction? So just look at the chain part on the top of the table. It is having a mass of 1 minus x into m. So its weight will be what? 1 minus x into m into g. And there will be the normal reaction between the table surface and this. Particularly there is no movement, right? Which means what? Normal reaction is equal to what? 1 minus x into m into g. That is a normal reaction. Coefficient of friction is 0.25, right? 0.25 means we can take it as 1 by 4. So the frictional force, will be what? Frictional force will be mu into normal reaction. What is it? 1 by 4 normal reaction is what? 1 minus x into capital M into g. Now this frictional force should balance the weight of the hanging part. Means what? Weight of the hanging part is what? X into m into g, right? So x into m into g should be balanced by what? The frictional force, 1 by 4 into 1 minus x into m into g. So mg is cancelled, cross multiply, 4 will go to that side, numerator. So what we'll have? 4x is equal to 1 minus x. Again rearrange. What do we have? Minus x, when we bring it to the left side, it will become plus x. 5x is equal to 1, which means x is equal to what? 1 by 5. X is equal to 1 by 5 means 0.2 is the fraction. But if you look at the options, right, what they are giving us? They are giving the options in terms of percentage. Fraction is 0.2 means percentage is what? 20%. So what we did in the question, we took the fraction of the chain that is hanging. Whatever is the weight for this fraction x, total mass of the chain is m, means mass of this hanging part will be what? Fraction of the chain hanging into capital M. Into g will give us what is the weight acting on this part. The weight of the hanging part is balanced by what? Frictional force acting on the chain that is on top of the table. That is the concept. Next we have another theoretical question. This has come in the year 1991. When milk is churned, cream gets separated due to. So here they are saying, different force terms. Option A, they are saying centripetal force. Option B, they are saying centrifugal force. Option C, frictional force. Option D, gravitational force. So what is the force that will basically separate the cream from the milk? To understand this, right, we should study a little bit about the idea of what we call as a non-inertial frame. Now we don't have numericals based on this non-inertial frame, etc., but we can have some theoretical questions like this coming in the NEET examination. So what is this non-inertial frame? Let us look at the visualization. Take a look at it. What is happening when initially the disk is at rest, but as the disk is starting to rotate, what is happening? This sphere, right, is not able to stay there. It is in fact moving away from the center of the disk. How this sphere is moving, the sphere which we are keeping on the disk, right, how it is moving? It is moving away from the center of the disk. This is a very common observation that we see. Like even when you are going for any theme park or something, right, you are sitting somewhere in the middle, the ring just starts rotating, you will get a feeling that you are being pushed towards the periphery of that particular disk. So why does it happen? It happens because, see, if the disk is rotating, means if say the sphere is here, if the sphere also has to rotate, somewhere, then sphere must have a force acting towards the center of the circle, because every particle which is going in a circular motion, right, every particle which is in circular motion should have a force acting towards center of the circle. What do we call that force as? Centripetal force. What do you call it as? Centripetal force. And if that force is not there, means the particle will not be able to continue in that circular path. So generally the centripetal force requirement will be m into v square by r. So if, say for example, the particle is in a circle of smaller radius, look at it, r is less, means what? The centripetal force requirement will be high. That is the reason why if a car is taking a turn, if a car is taking a very sharp turn, right, what is going to happen? The circular path radius will be small. So to take the sharp turn, there will be a large requirement for the centripetal force. If the centripetal force is not coming because of the friction, generally for the taking turn of the car, right, friction will provide the necessary centripetal force. If the turning is very sharp, means the centripetal force provided by friction will not be sufficient to meet this mv square by r value. As a result, what we'll see is that the car will be generally skidding away. So that what happens is, when it is skidding away, the radius of the circular path will become now more. So as a result, the centripetal force requirement will be what? Less. This is a very common observation that we do in case of the skidding of the car when we are taking a very sharp turn. But if we look at the situation here, right, for any particle which is not able to meet the centripetal force requirement, it will not be able to continue in the circular path. Then what we see is that it will appear as if it is going away from the center of the circle. Like say for example, if we are sitting on top of the disk, imagine we are sitting on top of the disk, then what we would be able to see is that with respect to us, so this is the observer, okay, so this observer who is already on a frame that is accelerated. By the way, this observer is having acceleration. Why? Because he is going along with the disk, means what? he is having a centripetal acceleration. So the observer, we call it as what? Non-inertial frame. Any observer who is having acceleration will be called as what? Non-inertial frame. So with respect to this observer, right, what you will see, for him it will appear as if the sphere is moving away from the center. So it is like there is a force acting on the sphere which is acting away from the center. But in reality, there is no such force acting on the sphere, right? The sphere is not able to meet the centripetal force requirement. That is why it cannot go in circular path. So it is moving away from center of circle. But with respect to this observer, right, who is sitting on the non-inertial frame, what he will visualize is there is a force acting on that sphere which is acting away from the center. So this force is called as the pseudo force. What do we call it as? Pseudo force. And particularly in this case, right, the observer who is sitting on this disc will feel that there is a force acting on the sphere which is away from the center of the circle. In reality, there is no such force acting on the sphere away from circle. But he would be visualizing that there is a force acting on the sphere which is acting away from the center of the circle. So this pseudo force is basically going to be called as the centrifugal force. So centrifugal force is not a real force. It is a pseudo force that will appear to be acting on the particles when we see them from a rotating disc. So if the observer is sitting on the rotating disc, right, he will see that, the objects for which the centripetal acceleration is not met, they cannot continue in the circular path, so they will move away from the center of the circle. So this will appear like there is a force acting on them which is away from the center of the circle. That is why they are moving away from center. This pseudo force will be called as what? Centrifugal force. So generally what happens is the larger masses, like say for example, if we keep a disc, imagine we have sand, all sand particles are there. All sand particles are there. Okay. So small particles are there, large ones are there. If we suddenly start rotating it, the ones that have a higher mass, look at their centripetal force requirement, m into v square bar. So the centripetal force value will depend upon the mass. Smaller ones, they will require a lesser centripetal force. So what happens is the larger particles, right, for them the centripetal force through friction between the the sand particles and the surface will not be met. So as a result, they will not be able to continue the circular path. So they will be drifting away from center of the circle. And you see that all these large stones, right, will be accumulating at the periphery or the boundary. So which means what? The heavier mass generally will not be able to meet the centripetal force requirement, and hence it will get drifted towards the boundary. That is what exactly happens in the case of the churning of milk also. Churning of the milk, the cream, right, milk cream will have a heavier mass in comparison to the normal particles of the milk. If you consider milk to be like a colloid, in chemistry you will study about it. Okay. So what happens is as you start churning them, like whether we talk about churning of the milk or even churning of the buttermilk, that is something that we see very often in our homes also. Like nowadays not many people are actually doing it. So churning of this milk or buttermilk, when you do it, right, what you will see, all the heavier particles, they will start drifting away from the center of this circular path that we are creating. So as a result, we will see them on the boundary. So here we will assume that this movement is because of what? Because of the centrifugal force. But in reality, is the centrifugal force a real force? No, it is not a real force. It is what? A pseudo force. Like the way we are observing the movement of the sphere with respect to the disc. What is the observation? It will appear that the sphere is going away from the center of the disc. There is a force. Reality, there is no force acting on the sphere. There is a force acting on the observer itself. The observer himself is having acceleration. So what do we call such observers as? Non-inertial frame. Such observers will be called as what? Non-inertial frame. Okay. So whenever we look at the motion of anything from the non-inertial frame. By the way, what is the answer for this question? We have to give the answer as what? Centrifugal force. But talking about the non-inertial frame, right, whenever we are observing anything, like say this is the non-inertial frame, okay, we are seeing the motion of an object. This is the object. Using the relative motion concept, if this non-inertial frame is having acceleration a, then with respect to him, the object will appear to be having an acceleration minus a, because the concept of relative motion, right? Relative motion means what? We'll move on to the next question. This is a straightforward question based on the definition of impulse. A particle of mass m moving with a uniform velocity v1, it is given an impulse such that the velocity becomes v2. The impulse is equal to, so initial momentum is what? M into v1. Final momentum is what? M into v2. Impulse will be equal to what? Force multiplied by time for which the force is acting. Force is what? Change in momentum by the time taken into time. Time gets cancelled. What is impulse? So impulse can be measured as what? Simply change in momentum, that's it. Which means what? Change in momentum means final momentum is what? M into v2 minus initial momentum is what? M into v1, which is M into v2 minus v1. What is it? Option D is the answer. It's a straight question based on the definition of impulse. Next we have a question which is based on the explosion. This question can also be seen as a question from the system of particles. In fact, the same model question by changing numericals has come in one of the other years also. Same as it is. As it is question, the only difference is numericals are changed. A body of mass 5 kg explodes at rest into 3 fragments with masses in the ratio 1:1:3. So the 5 kg mass is exploding into 3 fragments. The fragments with equal masses fly in mutually perpendicular directions with speeds 21 meters per second. The velocity of the heaviest fragment is how much? So look at it, we have a 5 kg. This is initially at rest. Means initial momentum. So at rest means what is initial momentum? 0. Now when it is exploding, 2 of these equal parts, see how it is exploding 1:1:3. You know what it means? What will be the masses? M1 will be 1 part. Total number of parts are what? 1 plus 1 plus 3 means 5. So 1 by 5 into 5 kg, that is what? 1 kg. Similarly, M2 also will be what? 1 kg. M3 will be what? 3 by 5 into 5 kg, that is what? 3 kg. So the equal masses means what? 1 kg, 1 kg. They are flying in mutually perpendicular directions with how much speed? 21 meter per second, 21 meter per second. So if you look at what is their momentum, let us call them as, maybe P1 and P2. Let us look at the momentum 1 into 21, which is what? 21 kg meter per second. Here also what is it? P2 is also what? 21 kg meter per second. These are making right angles with each other. If you look at what is the resultant of these two momentum, P1 and P2 resultant. Remember in vectors we talk about the principle. Two equal vectors, both have same magnitude, 21, 21. Resultant will be in which direction? Resultant is going to be along the angular bisector. Resultant of any two equal vectors is what? Along the angular bisector. This is the resultant of P1 and P2. But what about the magnitude? Both are 21, making angle 90, right? The P1 plus P2, magnitude is what? Root of 21 square plus 21 square, that is what? 21 into root 2. That is the resultant momentum magnitude. Now the third part should have the equal amount of momentum value but exactly opposite direction. Third part is what? The 3 kg part. So 3 kg part should ideally move in exactly opposite direction along the same angular bisector line but opposite. Momentum magnitude must be same. Means what? The magnitude of momentum means if it is having a speed v, then 3 kg into v should be equal to what? 21 root 2 kg meter per second. So why are we saying the momentum magnitude must be same? Because if the P3 magnitude wise same as P1 plus P2 and opposite direction, right? When we add all three, it will become what? 0. So which means kg is cancelled, 3 ones are 3 sevens. So what is the v value? 7 root 2 meter per second. So the third part, which is the heaviest one, the 3 kg part, should be flying with how much speed? 7 root 2 meter per second, so that the total momentum will still be conserved. Initial momentum is 0 before the explosion. Final momentum also will be what? 0. So in this case, if the P3 is having the same magnitude as P1 and P2 and opposite direction, right? Then when we add them means it will become totally 0 again. So this question is based on what? The conservation of momentum principle in the case of explosion. Next we have a question that has come in the year 1988. Starting from rest, a body slides down 45 degrees inclined plane in twice the time it takes to slide down the same distance in the absence of friction. Means with friction it is taking 2t time. If without friction it is taking a time t, means with friction it is taking twice to slide down the inclined plane. So from this data we have to find what is the coefficient of friction between the body and the inclined plane. So look at it, we have two cases here. So we will just draw both the cases. The case 1, case 2. In both the cases, the same distance, which is the length of the inclined plane, is covered. From top it is coming down, means what? The total length of the inclined plane is covered in both the cases. This is without friction, smooth. This is with friction. Now what will be the difference? So let us say theta is the angle of the inclined plane. In this they have given us what is theta. What is theta? 45. Now without friction means along the plane down there will be that component of weight. What is it? mg sin theta. This will produce the acceleration. So first we look at this, is we'll call it as case 1. Case 1. So what is the force acting down the plane? mg sin theta. The acceleration that will come from that is what? Force divided by mass, which is what? G into sin theta. Now starting from rest, if you assume from the top it is taking a t time to come down. So without friction is t time, means the displacement x is equal to what? We'll use the relation s is equal to ut plus half a t square. U is 0, means half into acceleration is what? G sin theta into t square. Let us keep it as equation 1. Now come to the friction case. In this also we'll have the component of weight mg sin theta, but there will be also the frictional force which is going to act upwards the plane. Perpendicular to the plane we'll have mg cos theta balancing normal reaction, means normal reaction is equal to what? Mg cos theta. So frictional force is what? Mu into mg cos theta. Since friction is equal to what? Mu into normal reaction, right? Frictional force is what? Mu into normal reaction. So it is what? Mu into mg cos theta. So there is a downward force of mg sin theta. Frictional force is what? Mu into mg cos theta. Net force, what is net force? Downward force minus the upward force. Net force by the mass, m will get cancelled. That is the acceleration. Second case, what is the downward, down the plane, what is the acceleration value? It will be what? G sin theta minus mu g cos theta. Okay. So here what is the acceleration? G sin theta minus mu g cos theta. Now here also, when it is coming from top to bottom, same displacement along the inclined plane x is equal to what? Half into acceleration. Acceleration is what? G sin theta minus mu g cos theta into time square. What is the time here? It is taking 2 times. Now this is our equation 2. If you look at them, right, in both the cases left hand side is what? X. In both the cases LHS is what? X. Now what we'll do is just we'll equate both the terms. I'll erase this part so that we can use this space. Now we got the answer. It is just about simplification. We have to write down the displacement expressions in both the cases. Then from now onwards it is just doing the final steps of calculation. What do we have here? Half into g into sin theta t square is equal to what? Half into g sin theta minus mu g cos theta into 2t whole square means what? 4t square. Here t square is cancelled. Half is cancelled. In fact, g can be cancelled. What do we have? Sin theta, which is 1 by root 2, is equal to 1 by root 2 minus mu into 1 by root 2 into 4. So sin theta is 1 by root 2, cos theta is also 1 by root 2. Again 1 by root 2 also can be cancelled on both sides. So what do we have? If we take the 4 to that side, means it will go to the denominator. 1 by 4 is equal to 1 minus mu. Rearrange. We will have mu is equal to 1 minus 1 by 4, which is 3 by 4. So the coefficient of friction in this case is what? 3 by 4 means what is it? It will be 0.75. So all we are doing is writing down both the cases separately, one with friction, one without friction, and then accordingly writing down the expression for the displacement in both the cases. From there we are able to get what is the unknown value, which is the coefficient of friction in this case. So this is about the part 6 video and last part video on the past year NEET questions from the laws of motion chapter. We'll see in the next chapter.